But on 11 here, and then we'll do another one I know today in our notes. All right, it's not at all in a cleaned up order, I guess I would say. So when we do that, again, completing the square not once but twice here, we need to have the x's kind of all grouped together, the y's kind of all grouped together, and then taking that constant term and kicking over to the other side. All right, so that's the first thing I'm going to do is get that all kind of a little bit cleaned up, a little bit, again, just better form. All right, so as I do that, all right, do it down here, x squared, and then a 10x is fine, and there it is. Leave yourself a little bit of room, right? We're going to create a perfect square trinomial, y squareds. Now, on that y squared there, I see I have a negative 30y. It's on the right-hand side. Add it over, right? And then leave yourself some room. Equal sign. Now, on the right-hand side, I'm taking that 241, and it's going to be a negative. Okay? There it is. Now we're ready to go at it with creating that u constant for the x, u constant for the y, that are going to, again, create me two perfect square trinomials. We've done a lot of that with, again, completing the square. It's always 1/2 times that linear coefficient, 1 squared. Half of 10, 5 squared is 25, not just on the left, but also on the right. Okay? Now, here on the next one, 30. Okay? On that 30 squared is, sorry, let me try that again. Half of 30 is 15, and then 15 squared is 225. So there it is, 225. Not just on the left, but also on the right to keep that thing, my finger got in the way of the camera there. 225 to keep that thing balanced. Okay. And there is my now two perfect square trinomials that should factor into the same two quantities. Okay. So x squared plus 10x plus 25 is x plus 5. And if you haven't noticed that pattern here, it's always that half of 10. It's always that half of 10. It's the square root of 25. It's always those factors. And then on the y's, it's the same thing. It's that half of 30. It's that square root of 225. That's its factors. So in this case, the square root of 225 is 15. And then on the right-hand side, add those up. Now that's going to be equal to, not r, but what do we say the right-hand side is equal to? Thank you, Eric. It's my radius squared. So from yesterday, we said that is our new formula for a figure out there. Lines, y equals mx plus b. We have quadratics out there. Quadratics, y equals mx plus b, we've been using for years and years and years. This second semester for quadratic, we've been talking about standard form for quadratic. This gives you a parabola. This gives us a line. And now we got ourselves a circle. Now, the quadratics has a few different other forms we use. We've seen a couple different ones. We just haven't had a chance to go deep down into that. Algebra 2, you definitely will. Now, our circles, as Eric reminded us, this is going to combine to give us our squared, which when we add that together gives me a 9. Okay? And there's my circle now. When we extract out that center, it's not 5 and 15. It's always the opposite. Because when I look at our equation there, it's negative h. And that negative h is, again, extracting out the opposite. That's why they said negative 5, negative 15. And then that r squared equals 9. So square root that thing. That's our quadratic work coming back into play. Technically, we get two solutions, but it does make sense to have a negative 3 for a radius. So that's why we only keep the positive solution. Okay. So we're going to do more work with that here today. Get good at it. Preparation for next week. Okay. Anything else on that sheet? Brianna, which one? 13? Sure. Let's talk about 13. Now, when I look at 13, even when I look at 14, they look one and the same, but the biggest difference is one says area of the sector, one says length of the arc. And the difference between the two is, am I using pi r squared or am I using 2 pi r? They all are set up the same way. It's the arc of the, it's a fraction of the circumference or a fraction of the area. So they all start off the exact same way. The difference is, am I using pi r squared or am I using 2 pi r? So when we talk about area of the sector, sector is always associated with a fraction of the area. So pi r squared is happening here. And when we talk about length of the arc, we're talking about fraction of circumference. Length of the arc is then associated with a fraction of the circumference, 2 pi r. And then right after that, got to know what the radius is. 19. 19. That one I don't know off the top of my head. 19 squared, 361. So 361 pi. The arc we're talking about, the sec that we're talking about is 150 over 360. And on this other one, I'm just going to work at the same time. Radius is 18, so 2 times 18, that's my circumference, 36 pi. And we're talking 225. So 225 over 360. And then we just go to our calculators, and hopefully we come out to 1805 over what? 12. So 150 over 360 times 361. Times what is it? 361. That's ugly. So we map it out, and that's where I get that 1,805 over 12 pi. Okay. And the same thing happens on the other one there. If I plug that into the calculator, pretty sure I get that. Okay. So that's your biggest thing. Make sure you get cleaned up by next week. All right. Make sure your name's on it. Throw in the basket. Get out your books. All right. Let's sit. Alrighty. Sorry, that's from the this morning. Okay, so from here, checking that, check with me. Somebody get the same center, same radius. Yeah, radius. All right. We've done a few of these, but again, we've already done the heavy work with completing the square. Okay, so making sure you getting that practice in over the next few days. We keep doing a ton of these together, but you got to make sure you're doing that work, asking the questions, checking that online with your answers. Let's move on. Okay, let's move on to the next couple pages where we're going to continue doing our work with the equation of a circle. And the next page we're going to look at is, I believe, right here. Finding this page, which is page, I don't know, 24, 724. Okay, so we got 724 here. We're going to give you some work with our equation of the circle. And we're being asked to find some not nice points. Are they lying on that circle or not? Okay. So on 724, question 3 here. We've got this circle with center located D at the origin. We got a point on there that we know for sure, point P at 8, 0. Okay. What we're trying to figure out is if point H, which is not necessarily a nice point, 5, square root of 38, is it lying someplace on that circle D? All right. So we want to try to figure out if that's lying on there. Now, there's a few different ways we can figure that out. What I like to do is go back to something that is familiar to you. And what is familiar to you is your equation work. If something is a solution to an equation, what should happen when you plug in things to an equation? It should check out, right? The left should equal the right. So let's use that skill with something you guys are already familiar with since, again, your middle school years. You know, when you start solving equations, what did your teachers typically ask you to do? Get x and do what with it? Plug it back in to make sure it checked out, right? Typically that what happens. Do we still do that all the time? Probably not. I get that. But that's what I want to do here. So let's first off, write me the equation of that circle. Y'all can do that. We started that yesterday. Write me the equation of that circle. What's the center of that circle? What's the radius of that circle? You've got the equation now, right? That's pretty straightforward. Our origin is the center, isn't it? So x squared plus y squared, right? Do we need to say x minus 0? No. Y minus 0? No, we just said x squared plus y squared. And what's our radius up there? Yeah, we can clearly see the radius is 8. So what does that equal? Don't say 8. We say 8 squared, which is, all right, 64. Don't forget to square that out, 64. So that's my, that's the equation for that circle. So what we want to go through here and do then is figure out if a specific point, 5 square root of 38, is in that circle. It's lying, I should say, not in, but on that circle. That's just a point. X and Y representing points on that circle. So let's go and plug in X and Y, 5 square root of 38, for that. So using that now, does that check out? Okay. This is the same idea that we've done with Pythagorean theorem. Does it make a right angle? Does Pythagorean theorem work out? So just go straight to your calculator. Take the left-hand side and use those parentheses, particularly on the square root. Square root of, what was it, 38? Now, yesterday I was helping some people. What's wrong here? It's underneath of it, right? It needs to be on the outside. Small things, be watching out for that. Okay? If that point, x, y, 5 square root of 38, squaring both of those adding together equals 64, that means it's on the circle. The equation is balanced. If it's not balanced, then it's not on that circle. Okay? Does it give me 64? No, what's it give me? Close, but not quite. So is this a point on that circle? No. So we're going to say then it is not on the circle. So go through and just tell me a little bit more, yes or no. All right. If you just say nothing there, I don't know, and then give me some your work to back it up. Okay. And that's all I'm looking for. It's the same thing we just did with the Pythagorean theorem way back when we were trying to determine if there's a right angle, right triangle, yes or no. You showed me the Pythagorean theorem was working. So I want to try to bring in previous stuff, not just add on something like a brand new skill to you. We gotta do enough as it is. So bring in some of those prior knowledge skills. Same thing with the next one. Yeah, we gotta bring in the equation of a circle. Yeah, that is a brand new thing. But after that, let's bring in some old stuff. So go and try the next one out with me. Okay? Give me a second to try that next one out. Create me the equation of, okay? So, nothing too crazy really there, just using our equation of a circle. All right, let's keep jumping around here, and I'm not worrying about that. And I don't think I want to worry about anything on that either, because it's going to basically ask you to repeat that same thing. All right, the last part I'm going to work on here with you is, I'm going to carry you a little bit more into tomorrow. Keep flipping right there, wherever that page is. 7:30. All right. Last part, 7:30. So we've done some work where we brought in our system knowledge. Right before spring break, I told you in preparation for some SAT work. I'm sure you probably saw a little bit of that work on the SAT. And I said at some point, um, you would continue to just kind of take you guys to the next level with systems. We just kind of keep it a little bit uglier. And here you go. Here's the opportunity for you. Okay. So we are going to work now through combining our work with our equation of a circle and our line work, where we're asked to find this intersection of a circle and a line. We're going to go through, do it by hand, and then we're going to check it with our calculator too. Now, our calculator is not going to be very helpful for our 84s. I'm just going to show it on decimals, okay? But we're going to do these by hand, because our calculator is not very useful, the 84s, to do that with. All right. How are we going to go through here? We got a couple methods. We got substitution, we got elimination. Anybody want to throw out which method then we're going to use to tackle these with? Definitely substitution. Because as we look at this letter A, we have a y equals, don't we? And nothing even looks like it's set up for elimination. Elimination, you have similar things that will add up and combine and then eliminate. So we are definitely going to tackle substitution. Substitution is probably your most common form to use. So let's do that. We're going to substitute in, as Jillian said, we're going to substitute in that y equals up to the top one, just like we, again, reviewed a little while ago. It says y equals, so we're going to replace that y right there. Let's rewrite that top equation. All the y's are going to come out. All the x's are going to come in. X squared. Now, it says y squared. Instead of y, it's going to become parentheses. 2x minus 20. Thank you. It needs to have a squared there. We have not had a chance to talk about a quadratic system. I think I might throw out one or two examples. I just know I didn't have the time for it. Now we do. All right. Let's work it out here, guys. Now, this is just our next steps. Okay. We got x squared and we got that kind of ugly mess there. 2x minus 20 squared. How the heck we're going to deal with that? Expand it out, multiply. Take 2x minus 20, expand it out, multiply together. You guys have been doing polynomial work with me since January. Take 2x minus 20 times 2x minus 20, pause. Take it off to the side. Let's take it off to the right because I am going to do letter B with you guys. And let's take that off to the side and do your multiplication for me. Okay? Let's do our multiplication there. Expand it out. Get whatever trinomial that is. All that polynomial work that we've been doing with factoring and adding and multiplying and all that jazz comes kind of combining your systems now. And Algebra 2 is going to just keep going with you. We got 4x squared minus 80x plus 400, I think. That close shaking that arrow shaking that says. Make sure you're checking your work with 9. It's easy to screw up stuff, so double check them, just drag my feet, give you a chance to do that before me. All right, I'm going to take a look here. I'm going to start bringing that back into my problem, putting this thing into what we know. It's a quadratic. Quadratic, we have several ways to solve this. Square roots, factoring, complete the square, quadratic formula. We get all 4 methods out there, guys. Let's combine that into standard form and figure out what in the world we're going to do. So as I start bringing that back in, remember, this has become this. I'm combining like terms. 1x squared and 4x squared. gives me a 5x squared. That's a minus 80x. There's nothing to do with that. Now, 400 and that 100. Let's think about this. That 100 I'm going to bring to the other side to combine with 400. What's that going to give you? 300, right? Equals. So I got a 0 there. Checkmate. But all I did is put in standard form. Plus. Okay. Thing I notice is I got some big numbers. When I got big numbers, what are we going to look for? Looking for a what? GCF. 580, 300. I got a 5. Let's take that 5 out. It's going to reduce our sizes. If I take out a 5, 80 divided by 5 is? You don't know? It's what, Claire? 16. Yep. 300 divided by 5 is? 60. I'd much rather work with that now. That is much easier to work with, isn't it? Now you got 4 methods here. Again, we want you guys, I'm not expecting you guys to still be like super confident, like how to solve these, or be super efficient yet. But let's think about here. Square roots ain't happening. Square roots, I gotta have no linear term. Can't do that. Okay, complete the square can now happen. That 5 is essentially gone. I don't care about that 5. I can even erase that 5. We brought everything down by 5. The 5 is gone. I could do complete the square here. I could try to factor. I would try factoring. A is 1. It's worth my time to try to find factors of 60 that give me negative 16. Me talking about that, I could be done by this point. Or my other backup is quadratic formula. Quadratic formula takes anybody. The quadratic formula probably takes a little bit longer than me trying to factor this, and it might turn out to be a factorable 1. Or complete the square is pretty quick as well. Okay, so you got 3 methods. I'm gonna again look at this thing. I'm gonna realize factors of 60 that give me a 16 are 6 and 10. Okay, so all this time I've just been talking here, you should also realize at this time of the game, 6 and 10 are doing it for me. So again, we want you to be able to just solve them, great, but being smart and efficient about how to do that. 6 and 10. What do we know about our signs on 6 and 10? Yep, they're both negative. My solutions. Zero product property says one solution is 6, the other solution is 10. I got 6, I got 10 for x. Cool. But what have I not found yet? I have not found y. Let's go find y. Now with substitution method that Jillian said about 20 minutes ago, okay, we're going to use that one that I put in parentheses and say, hey, when x is 6, what's its output? What is its y value? 2 times 6 minus 20. 2 times 6 minus 20. 2 times 6 minus 20. You should be able to just think about it into your head, or calculator says. Somebody got negative 8? That's my first point. Okay. One solution is 6 comma what? Negative 8. One intersection is 6 negative 8. And then what's the other option? 10. So 2 times 10 minus 20. All right, you all can do that in your head. 2 times 10 is 20. 20 minus 20 is 0. X is 10, y was 0. So there are my 2 intersections. I get 2 ordered pairs as my solutions. And think about it. That should make sense, Because what is a possibility when you have a circle? That's a circle. That's a line. How can the line and a circle intersect? 2 points, right? How else could a line and a circle intersect? How many points? What do we call that? Thank you. Thank you. How else could a line and a circle, do they have to intersect? And if they don't intersect, how many solutions do we have? 0 or no solutions. So we could get a 1 solution, we could get a 2 solutions, or we could get a no solutions. Okay? Those are options for a circle and a line. Okay? Can we get 3 solutions? No. Okay? It's a line. It can't curve back on itself or anything weird like that. Okay? All right. Trying to think here. What do you want to do? One more or call it? One more?
Call it.
All right. We're going to do some more. We'll do these tomorrow then. Okay? We're doing the same thing, but we're going to do these tomorrow.
Call it.